Hi guys, I just wanted to briefly go over the changes that are happening for the new exam, for the modified exam for this year. So first things first is that the date is changing, so it's going to be on Monday, May 18th at 2 p.m. rather than May 11th. So we will have an extra week. The test is going to be 2 questions. It'll be a 25-minute FRQ with 5 minutes to submit your answer, and then another 15-minute FRQ with 5 minutes to submit your answer as well. So total 45 minutes. You can use a phone, an iPad, a tablet, laptop, desktop, anything that you have that has internet access. If we are back at school, you'll be doing this at school. That is not likely to me, so you'll most likely be doing this at home. So I think all of you guys are good on the whole technology thing, but if you're not, let me know that you have like issues with technology or internet or whatever, and you can also go to collegeboard@cb.org/tech by April 24th to submit those like claims of issues or anything like that. Okay, so you'll have two options. Honestly, I don't see the point for the second option for either or any of you, but you do have the option. So the first option is you're going to be typing your answers on your electronic device. So for those of you that have very bad handwriting, you're in luck because you'll be typing them. The second one is handwriting your answers, taking a photo with your phone, and then submitting using your electronic device. Hopefully this means that there's no graphing or drawing for the exam because you'll just be typing words, but I am not entirely sure how that's going to work. Yeah, so for the 25-minute FRQ, I sent you guys something that looked like this through GroupMe, but here it is. So the first question is going to be 25 minutes. It is an 8 to 10 point question, and there are 4 parts. So you're going to be presented an authentic scenario that is going to be accompanied by either data in a table or a graph or both. And then you'll have to do a couple of things. So for part A, it's between 1 and 2 points. You'll be describing and then also explaining a biological concept, process, or models. And then part B, which I really want to concentrate on part B for the next couple of weeks. I want to concentrate on all of them, but part B is identifying experimental design procedures. I think that if you have this down, which it's pretty easy, but if you have this down, then you can get those 3 to 4 points easily. So these are things like experimental controls, independent and dependent variables, things like that. So things that you should know, and you should be able to get those points. Part C is analyzing data, and I'll talk about a little bit more of what that means in a second. And then part D is making and justifying predictions based on that data that you're given. And then we have our 15-minute question. Again, you're going to be presented an authentic scenario, not based on data in particular, but it's going to be like a biological phenomenon that has a disruption, which we've seen these in our FRQs before, whether it be cell-to-cell communication or whatever it is. There's always this disruption, and we're always told to analyze that disruption and predict what would happen if that disruption happened within the biological phenomenon. So we have 4 points again, or parts again, and it's also out of 4 points. So this is about half the amount of points that the first question was, but still very important. So part A is going to have you describe the biological concepts or processes. Part B is going to have you explain a biological concept or process. And then part C will make you predict the cause or effect of a change in the biological system. So you're going to be given a disruption, and you're going to be asked, how does this disruption affect cell-to-cell communication or transport through the cell membrane, whatever it is, it's going to ask you how that's going to affect the process of whatever it's talking about. And then part D is going to be justifying that prediction that you present in part C. Okay, so Monday, May 18th at 2 p.m. is the normal date, and then if you cannot make it, there's a makeup date on Wednesday, June 3rd, at 4 p.m. So this is only if you have a conflict with the May 18th date, and you also have to have that validated by your school. So if you cannot take this exam on May 18th, you need to contact the school, and they need to validate your reason. Okay. And then exams will be returned to us teachers by May 26th, so we can look at your work, which is kind of different from what they usually do. But before your exams are even scored, I can look at them and validate them and make sure that nothing went wrong with the process. So we do have 6 weeks. I think that's a lot to review. And I think that if as long as we are practicing and making sure that we have all of those points, then we will be golden. Again, this is an open note exam. So as long as you have the concepts down, you just need to be able to apply those concepts and analyze data, and you should be completely fine. Okay, so I did put this in a Word document just so you could see that. So this is the Word document. I did put some of the skills that explain what you will be asked to do a little bit more. So for example, part B says identifying experimental design procedures, and this can include identifying dependent or independent variables. It can include identifying appropriate controls. Remember, we've talked about positive and negative controls. Those are very popular in AP biology, and they could absolutely ask you the difference between the two controls, or why a control was missing, or what control is present in the experiment. So just make sure that you have your controls down and your concept of controls down. And then you can also be asked to justify the appropriate controls. When it asks you to analyze data, this could be that you are going to be asked to calculate means or rates or ratios or percentages. It can also ask you about confidence intervals and error bars that we've done. We definitely will have to practice those, because I know you guys had some trouble with that. You might be asked to do chi-square, and you might be asked to reject or fail to reject a null hypothesis. And then so that's the analyzing data part. You could be asked to do any number of these. All right. So I also put the task verbs on here. So these are all the task verbs that are in my classroom right now. Just make sure that you go through all of them and make sure that you know exactly when the test says, for example, describe blah blah blah, you know exactly what you're doing. So for describe, it says provide relevant characteristics of a specified topic. So pretty easy, straightforward, just describe some characteristics of this concept that it's asking you about. But when it asks for explain, this is a much more in-depth response that they're asking for. And you guys might not know that, but you need to look at these task verbs in order to understand what exactly they're asking you for when they say each of these. So explain means provide information about how or why a relationship, process, pattern, position, situation, or outcome occurs using evidence and or reasoning to support or qualify a claim. Explaining how typically requires analyzing the relationship, pattern, position, situation, or outcome, whereas explain why typically requires analysis of motivations or reasons from the relationship, or for the relationship, process, pattern, position, situation, or outcome. So this is a much more in-depth, like you need to, like I said in the lecture from Monday, you need to take that concept and explain it as if you're explaining it to someone who has absolutely no idea what you are talking about, hasn't ever taken a biology class. So when it asks you to explain, you need to be thorough. You don't need to put fluff pieces in it. You don't need to make unnecessary comments, but you need to explain it very thoroughly. So just make sure that you go through all of these. They're all a little bit different, and make sure that you know exactly what it's asking of you for each of these, especially the ones that are explicitly in these questions, like describe, explain, predict, justify, etc. So make sure that you look through these and then go down here and look at each of the task verbs so that you know what they're asking you to do. Okay, so that is it for the new exam. We're just going to keep practicing. I think that I will do a vocab quiz on Wednesday of next week. On Monday, we'll talk about plasma membranes, but I do want to really quickly talk about cell size. So this is a really short. So we're still going to do Unit 2. That was all that I wanted to talk about for AP, or sorry, for the AP exam. And then we'll just keep trucking along with Unit 2. So this is just about cell size. I just want you to see this really quickly. We know that cells are small because of surface area to volume ratio, remember? So cells have to be big enough for materials to get in and out because they need nutrients, they need resources, they need to get rid of waste, they need to dissipate thermal energy if they get too warm. So they need things to be transferring in and out of the plasma membrane. So cellular metabolism depends on cell size, and then at a certain size, it begins to be too difficult for a cell to regulate what comes in and out, and what comes in and then what goes out of the plasma membrane. So there is a happy medium. So the size of a cell will dictate the function. Cells need a high surface area to volume ratio, like I said, in order to optimize that exchange of materials through the plasma membrane. So we talked about these formulas for surface area and volume. These formulas will be on the AP exam. So you'll have these formulas for you to use if it asks you to calculate surface area to volume ratio, for example. So surface area is just height times width times number of size times number of boxes, and then volume is height times width times length times number of boxes. And then your surface area to volume ratio is just surface area over volume, so just divided by volume. So the formula for spherical cells are surface area is equal to 4 pi r squared, and then volume is 4/3 pi r cubed, and then surface area to volume ratio, again, is just surface area over volume. And again, all the formulas will be on the AP exam for you to use. So an example, I'm going to go through these really quickly because again, you'll have the formulas on the AP exam, so I won't need to practice too much with you guys. Plus, you've done this before, you've seen this exact slide before. So the question is, which would have the best exchange of material through the plasma membrane? So it gives you number 1 is a large cube, and then number 2 is many cubes that are all together. So if we look at the surface area for number 1, we have 3 by 3 by 6 by 11, and this is going to be, the surface area will be 54 units squared. And then we have the volume, which is 3 by 3 by 3 by 1. Sorry, I think I said 11. So the volume is 27 units cubed here. The surface area to volume ratio is going to be 54 over 27, and then that will be 2. Whereas here, you're doing the exact same thing, but now we have 27 cubes, and they're all a little bit small, or a lot a bit smaller. So you end up with a surface area to volume ratio of 6, which is much larger than number 1. So option 2 will be better, more efficient for the exchange of material through the plasma membrane because the surface area to volume ratio is much higher. And this is going to be the same thing for spherical cells. If you look, and I won't go through all this dimensional analysis, but if you look at surface area to volume and you put the formula for surface area and volume together, you can simplify these. 4 gets knocked out, so we end up with 1 and then 1 over 3. You can knock out pi, you can knock out r squared, and then you end up with r, and then we get 3 over r. So as r increases, the ratio of surface area to volume will decrease. So as this gets bigger, as the radius gets bigger, the surface area to volume will get smaller. So just looking at these, you know that this one will be the most efficient, right? Because its radius is much smaller. And you can look, or you can do that mathematically, and that's what this is. So the surface area to volume ratio here is 0.6, whereas the surface area to volume ratio here is 0.37. You can do that mathematically. It might ask you on the FRQ. I kind of doubt it, but it might. So if you want to practice that, then you are welcome to. But you know that option 1 is better because the surface area to volume ratio is higher. Okay. So cells tend to be small, that's why this is relevant. They're not too small because if they were, say, the size of an atom, then nothing would get, to them. There would be no exchange of materials. It would be way too small for any efficiency. But they are small because they need that high surface area to volume ratio in order to exchange more materials in and out of the cell. So this optimizes the exchange of materials at the plasma membrane, whereas larger cells will have a lower surface area to volume ratio. They'll lose that efficiency in exchanging materials, and the cellular demand for resources will increase. And the rate of heat exchange also decreases, so they won't be able to get rid of the excess heat from all of the cellular processes and reactions that are happening in a cell. All right, so that is it for this. I just want you guys to make sure that you are, even if I am not telling you to study, I need you to study because there's not enough time in the world for me to lecture absolutely every piece of information to you. I'll also post some videos on, I'll keep posting videos. Some of them will be Bozeman, some of them will be like other things. I'll post some about the experimental design that I want you to work on, and then also Unit 2. We'll keep going in order from Unit 1 to Unit 6 again, and just review all of that, and then we'll do some more practice FRQs. So be ready for talking about plasma membranes on Monday and also doing a couple of practice FRQs. Okay? All right, I'll see you guys